Hello and welcome once again to ICT Lectures. So this is a channel that we dedicate to producing simple and easy to understand ICT related tutorials, right? So today we are going to look at computer architecture and organization, right? So kindly don't forget maybe to comment where you are, which school you are from or university, right? And any kind of lecture that you want us to produce so that at least in our subsequent tutorials we can always accommodate your requests, right? So what is computer architecture and organization? So ideally, computer architecture, maybe just from a layman's understanding, we know that those people who draft or build or design our houses, we refer to them as architects, right? So they build the house from foundation, right? So without that foundation, proper design and everything, we can't really have our houses, right? Or our structures. So simply put, computer architecture is the drafting of the structure of the foundation of a computer system. So when we talk about computer architecture, then these are the basic attributes of hardware components and how they are connected, right? So it requires some deep understanding of how these particular connections and interconnections happen, right? But today we just want to familiarize ourselves with what it is and maybe to understand more about how computer is built up, right? So yes, it refers to those attributes of the systems, and they have impact on how we maybe perform memory addressing, how the input-output devices communicate, the instruction set, right? So architecture is the fundamental principles of how a computer is actually built. So we can also look at organization. Now organization now depends on the architecture. So once you have the architecture built, now you can design, right? The physical, it actually is the physical arrangements. So here's where someone is going to tell you that we have input devices, we have output devices, we have storage devices, right? So you are actually organizing those particular computer components into their respective functionalities, right? Or operational units. So it could actually bring some transparency and help maybe people such as programmers to develop programs that can help us control signals, create some interface of how different components can work together, and so on and so forth, right? So these two elements, that is architecture and organizations, are very, very crucial into understanding what a computer system is. So we can still look at the structure, as we have already mentioned. These are the way in which components relate to each other. How the CPU relates maybe to the main memory, how the input devices relate to the CPU. Because we are going to understand how this particular communication between the different components of this computer work. And then function is the operation of individual components as part of the whole structure. When we talk about a system, we combine the structure and function. We can't talk about a computer system without understanding how the various components relates and their actual functions, right? So function, we can look at functions of input devices as how in terms of helping to key in or to enter data, right? So all computer functions are data processing. We have already mentioned that. We can store data, data movement, yeah, and also of course the control function. We need to control how the different instructions are sent into and are received out of this particular computer. So the understanding of architecture highly actually relies on understanding of structure and function. We therefore need to understand then the various components of the computer. So you can see this particular diagram is this block diagram actually is going to help us understand how these components actually interact with each other. Then we need also to understand their respective functions, right? So this, you can see the arrows shows the interaction. Like for example, in the middle here, we have the brain of the computer, which is the CPU. So you can see the central processing unit interacting upwards with the main memory, and of course bottom it interacts with the secondary memory. On the left side interacts with the input devices, on the right side interacts with the output devices. So that is the interconnection, and that's how every computer is built, right? Now, we need to understand what these arrows actually mean. Now, for example, when you are entering data into a computer, it's normally stored within a temporary location. This temporary location is also referred to as the primary memory, or what we refer to as the RAM, random access memory. This primary, or rather secondary, temporary location, the name temporary actually means volatile, in that if maybe power goes, if your power goes, then you lose your data. So therefore, the primary memory only stores data temporarily. So when you type data, for example, using Word, and you don't save your Word document, it is stored within the primary memory. Now, if the CPU or the processor want to actually process what you have already typed, it then has to fetch the instruction from the primary memory, and that's why you can see there's a downward arrow pointing to the CPU. So that means it is fetching instructions from the primary memory. So once it has processed whatever you're typing, and once you save this data, the arrow points down to the secondary memory storage. So your data moves from the primary memory, then you save it to the to the secondary memory. So this could be your hard disk, your flash disk, your compact disks, name them, any storage device, right? When you decide tomorrow that you want to maybe edit your Word, what you normally do is to issue an instruction to the CPU to fetch that particular data from the secondary memory. So you open your Word document, and it opens, the CPU opens it and places it on the primary memory, so that you can edit and add other additional content. So you can see the back and forth communication between secondary memory and primary memory is actually done based on the central processing unit. So we need to have a control mechanism so that the CPU understands which data should be processed first, which one should be processed after the other, and so on, right? And we are going also to look at maybe how the CPU identifies which location to fetch the data from. We normally refer to them as memory addresses. Now, looking at the input device, the input devices are known to only send, they only communicate with the CPU in a one-way direction, not bidirectional, as you can see, the primary memory and secondary memory. So input allows you just to enter, key in, right? It sends instructions, right? That is the only work of the input devices. And then output devices are tasked to receive the instructions from the central processing unit. So you realize that also output devices cannot just receive, it has to get the signal from the central processing unit. That's why you can gets the signal that this is music, you need to listen to your with your speaker. This is some text needs to be displayed on the screen, and so on. So basically, these are the main components of the computer that forms the structure and the function that you've already discussed. So every part of the computer has its own function. So these functions and operations of the computer can be seen as the first function is inputting. We have already seen you can use the input devices to send raw data. You can store data within the computer. That means you need to use some kind of secondary storage or even primary storage. We can also do the processing, and the only organ allowed, not really organ, but component allowed to process data is actually the CPU. And of course, the output devices outputting are actually given the task to receive those particular instructions, right? And of course, we have the control function that maybe monitors what is coming into the system and what is going out. We're going to see how this control function, and it's actually part of the CPU. So in a nutshell, ladies and gentlemen, if you can look at it from a layman's perspective, whereby if you go to a grinding mill or a posho mill, right? Normally you take the grain with you, right? So this grain can be seen as some kind of raw data or facts. So you pour them to the grinding machine and they be grinded, right? And whatever output you get is the flour, right? So this process of grinding can be seen as the CPU. CPU is the one that starts to convert this particular raw data into some form of information. And of course, you'll have your bucket there. You place your flour. So this bucket can be seen as a what? It can be seen as a storage, right? It could be a secondary storage, right? And of course, the person controlling all these functions, it is you. So you are the user. So user also is a very important part of this entire operation. So going forward, as you can see, we indicated the purpose of input. You can see it's just to send data, and it's very important that you be able to identify the various input devices together with their functions, right? So that one you're not going to cover here, but I'll share with you some additional notes. In fact, you can go straight away to our website. Let me just show you. All right, so this is the website. You can come here. You can see there are some additional notes. We have computer architecture 1 and computer architecture 2. So once you're here, the name of the website is learnerscoach.co.ke, and within the information section here, you just type architecture and you search, right? So you can see part 1 of the architect. You can just click on that. Then it is going to give you additional information, right? If you want to proceed to part 2, you can also click on that particular link, right? So those are some additional notes that you can always use. You can see we have also identified some types of CPU, right? We have single core, dual core, right? You can see also the basic system architecture that you have mentioned, right? You can see the input-output devices, the memory here, the processor, right? We are still going to look at the processor in this particular lecture. We also have the buses. We are going to understand what the buses are. You can see the transfer. There's some kind of address, bus data, and bus control. Yeah, we're going to understand how we can always transmit data from primary memory to the processor and back and forth. So once you're done with part 1, you can also proceed to part 2, right? So these are additional notes. I'll share the link so that you can be able to proceed to the website. So let's go back to the presentation. So again, you can have a look at the output devices. You can see they are tasked only to receive data from the system or from the CPU. And of course, we have examples of these particular output devices. I hope you know them. Get to understand their function, which is very, very important. Then we have another category of these devices known as the I/O, input-output. These ones have the capability of sending and receiving data at the same time, right? So they're very unique. In fact, giving a good example is a headset. A headset has a combination of an input and an output. You can use the microphone, and again you can have the speakers in your ears, right? So that is an example. We also have modem that can be able to convert analog signals to digital signals, and digital signals back to analog signals. So those are kind of I/O devices, a very special category. Now, we talked about the structure, or rather the architecture of this particular computer. And the good example of this is the circuit board, known as the motherboard. We can also talk about system board or printed wire board, right? So this is a good example. When you want to build a PC, you need to have a motherboard. And you can see it has additional components, very many components. I can see we have the PCIe slots, yeah, a peripheral component interconnect. These are just expansion. This white part, right? They are expansion buses that allows you to add additional expansion cards. I can see also we have the CMOS battery, right? A complementary metal oxide semiconductor that stores the system settings or the system timings, right? CMOS also is a good battery that computers use. And of course, we have additional peripherals. We have the CPU socket, the one at the center. That is where we place our CPU. Yeah, we have advanced technology system, power system. We have the notch bridge. There are quite a number of components. We can't really name them. We have capacitors. I can see them there. We have AGP, accelerated graphics port, south bridge, right? So the motherboard, I think that's where we get the term mother. It is actually mothering a lot of components, right? There are a lot of components. Ideally, almost 99% of the components get connected to the motherboard, or the motherboard, so that your PC can be able to function. So ideally, the CPU, as you have seen, it does the processing. The main memory, we have seen the work. Then you have the BIOS. BIOS is a basic input-output system. This is what stores the manufacturer's information. When you, for example, boot up your system, you'll see the manufacturer's information, whether it is from HP, it's from Dell. So that is the BIOS, right? It's very important. It's a firmware, actually. Then we have the CMOS, I've already indicated. We have also the cache. We're going to say what cache is and the functions of a cache memory. These are additional memory that actually stores frequently accessed instructions. We have the CPU clock that offers the processing time. Yeah, normally we measure these in hours, yeah, instructions per second. We have expansion buses, chipsets, and so on, and all these controllers of the input-output devices. Now, the big component that without it we can't really talk about the structure, or rather the architecture of the computer, is the processor, right? So processor here actually performs a lot of instruction, and that's why you need to understand the various parts of the processor. What happens when the processing takes place. I've already seen within the block diagram what it does. So processor, we talked about the analogy of being the brain of the computer. So you can imagine how the human brain functions. That's exactly how the processor functions. So it has different parts, and these different parts perform different functions. For instance, you can see we have the main memory, or the registers. We have the arithmetic unit. We also have the logic unit, control unit, and of course the cache memory. Now these are the crucial parts of the CPU, and we are going to maybe see what they do step by step. Like for example, the register. A register actually is a special purpose. It's kind of a temporary storage unit, right, that stores high-speed instructions, right? It's in fact, if we are to position a register, we can put it between the main memory, and the CPU, right? Just like the way we normally place the level 2 cache, right? So it's more or less the same, right? It stores very frequently accessed instructions, high-speed locations within the computer. Then you have the main memory. We have seen it is the RAM. The part of the computer, or the CPU, that is tasked to perform operations such as addition, subtraction, multiplication, division, is known as the AU, arithmetic unit, right? And we have also the logic unit. Logic unit, as the name suggests, is tasked to perform logical operations, right? Such as comparison, yeah, greater than, less than, right? And of course, we have the control unit, which plays a very crucial role in managing the flow of data information within the CPU. Ideally, without the control unit, the CPU can be overwhelmed with the instructions getting inside, right, from the input devices. And lastly, the other part that we need to understand is the cache memory. A cache memory, as I'd mentioned, it is almost similar to the register, right? So it is a small, very fast memory that stores frequently accessed information, or other data. Now, what happens is that if the CPU wants to fetch instructions, it first looks at the cache memory before going to the main memory. So once it finds it within the cache memory, it processes it very fast. So the time it takes to go to the main memory is going to be maybe eliminated. So that's why they normally say that when you have a lot of cache memory, your computer is going to process data very, very fast, because it is closer to the what? It is closer to the CPU, unlike the main memory. Now, what is the function of the CPU now that you have seen the various parts of the CPU? The main operations of the CPU can be concluded in 4 main phases. First phase is fetching instructions from the main memory. We saw the block diagram. So when you send or when you want to execute some tasks from the computer, first of all it is stored within the main memory. Then the CPU fetches these from the main memory. So that's what we refer to as the fetching phase. Then we have decoding. Decoding is actually when the computer, or rather the CPU, wants to understand what needs to be processed. So it needs to convert it, it needs to decode it, yeah, so that it understands that particular instruction. Then you have the execution. So it can only execute what it has decoded. So executing is another phase that we also need to understand. And once the instructions have been executed, then they can be stored, right, in the memory. Some can be displayed within the output devices and so on. So again, we looked at the structure and we saw that this is the interconnection, or how various components interconnect. And the most important thing when they're interconnecting is how they communicate, right? So we need to understand the communication within the CPU. And we can conclude that we have 2 major communication channels that can be seen. We have processor to memory communication. We have already seen how the processor fetches data or instructions from the main memory. So that is one communication. We also saw how the processor communicates with the input devices and the output devices, right? So these are the 2 main communication. So when you look at the processor to memory communication, it just doesn't happen anyhowly. There's some set of coordinated direct communication from the processor and the memory. So you need to ask yourself, when the instructions are stored within the main memory, how is the processor going to identify that this particular instruction is being fetched from this particular point and not this particular point? Now take a look. Where these particular instructions are stored, they need to be labeled. Now this labeling is what we refer to as addresses. So the instructions need to be given some addresses, and these addresses are stored in what we refer to as memory address register, so that the computer, or rather the CPU, can always recall where this instruction was fetched from. Then when these particular instructions are piled from the main memory and they're being processed, they're normally placed in a buffer, so that the first instruction is processed, then the second and the third. So these buffers are what we refer to as the main buffer, memory buffer register. So we have learned that when you want to change, or when the CPU fetches data, it actually does what we refer to as reading the memory, right? So when it fetches, that process of fetching instruction, we refer to it as reading the memory, right? And when it wants to process whatever it has fetched, is now what we refer to as writing the memory, like it's now executing that particular instruction. So these 2 read and write operations are very, very crucial in terms of processor to memory communication. Then we have the I/O devices. We have ports within the computer that are dedicated to input and output devices, and no any input or no 2 input devices should share the same port. So this communication is enabled through the interface unit, so that we have different ports for the different input devices. So that's where That's when the processor can be able to understand that this port is for keyboard, this instruction came from the port for the mouse, and so on, right? Then we have already looked at the cycles, and you can see we have talked about the fetching execute cycle. So the first cycle, as you have mentioned, is the fetch cycle. So here the computer fetches instructions from the main memory, it decodes it, it breaks it, it should understand it. I think you have already mentioned this. It then executes that particular information, or rather the instruction, and you can go ahead and store this particular instruction within the storage device, or you can display it, right? Then you have the bus, the coordination, how data is transferred from one part of the computer system to the other. So bus are generally a set of wires that are used to connect the different internal components of the computer system. A layman's understanding of the bus is like the road, a highway, right? So the larger or the wider the road that the vehicles uses, the more the vehicles can pass. You get the point, right? So the narrower the road, the fewer the vehicles. So in this case, take example of the road as the bus, as those set of wires, then the vehicles as the data. You understand? So we have a way of actually labeling also these particular buses, and that's what we refer to as the address bus. We need to give it. Now, currently we have wider buses, right, that transfer a lot of data. We have even one up to 128 bits, right? So yes, that is the main importance of the bus. Concluding our understanding on the CPU, you can see the components that you've already mentioned. You can see the arithmetic logic unit. So it's like the brain. So if you slash your brain, or you divide your brain into two, you can see whatever is inside. So we have actually slashed our CPU, and you can see whatever is inside the CPU. So you can see what is in the CPU, and of course there is also the diagram representation of what is in the control unit. So you can see the control unit performs decoding, memory control, right? So it does a lot of control. This is just an example of the structure of the CPU. Now, how the information flows or the data flows. So this is how we can actually summarize the whole concept of how the CPU functions. At the center is the main CPU, right? You can see the cache memory. It's inside the CPU, so it's closer to the CPU. Then you have the arithmetic logic unit. Yeah, it does the arithmetic and logic operations, and of course you have the control unit at the bottom. Then you can see the data labeled in red. So data gets we can get data from the input and store it to the main memory via the CPU, and you can also store, after it has been processed, it can be displayed, or it can be transferred back to the output, right? Then we have the cache memory connecting to the main memory. So that means the CPU has a choice of whether getting the data from the cache memory or going all the way to the main memory. And ideally we have the control function, the control unit. You can see it is controlling what is coming from the input and what is also being stored, right? So before the processor processes anything from the input, it needs to be controlled. And you can see the control unit is the one that is applying these particular instructions. Once they have been processed, it displays, or it has a choice of saving them within the storage, what is known as the auxiliary. So ladies and gentlemen, this is a very nice understanding of how the CPU function, and it's a very important component of the computer architecture that you have seen. And all these actually summarizes the organization of this particular architecture. Then we can also look at memory in threefold. We have looked at memory as the primary, that is the RAM, that stores temporary data, or what we refer to as data that is, or the instructions that are being handled by the CPU. We have secondary memory, that is like the hard disk, and then we have the internal process memory that is stored near the CPU, that is the cache memory that you have looked at, right? So we can represent this memory in some kind of values. The first, the smallest is what we refer to as the digit, or the binary digit. So when you have 8 group of bits, we can always talk about byte, right? Then when you have 1,000 bytes, we can talk about 1 kilobyte. When you have a million bytes, 1 MB. So this is how we can represent memory. So the larger the bytes, or the more the bytes, the larger the storage capacity that is required. Then you can say we also have 2 types of memory, static and dynamic RAM, right? So static is stored till the power of the computer is switched on. Yeah, so it's a bit, this one is a bit expensive, right? And then you have dynamic RAM, which is stored in storage cells consisting of, ideally when the computer is refreshes, maybe when the capacitor is discharged, whatever is stored in the dynamic RAM is normally lost, right? Then we have ROM. The opposite of RAM is actually kind of ROM. ROM is permanent. RAM is temporary. ROM is non-volatile. RAM is volatile, right? So we have devices that uses ROM, such as calculators and so on, and of course secondary storage devices. So ROM can be divided into 4 types. You have programmable ROM, right? So these ones are right operation of data can be performed. They're reliable. We also have erasable ROM that can be erased based on using ultraviolet light. We have electrically erasable ROM. This type of ROM which can be erased by destroying it, by exposing it to the electric charge. Ideally, how you can destroy or erase data is what informs the name. Of course, you have flash ROM that normally is used in most of the memory cards of mobile phones, digital cameras, iPods, for storing data and so on. So ideally, that is just a brief introduction to computer architecture and organization. So I think in our subsequent lectures, we are going to dive deep into all these components and understand what are their functions, right? So kindly be part of the family, and see you next. All right, thanks.